Alright, so the stream is back. I just want to check and make sure that it is in fact uploading. I just got done with doing 2 test videos, and now we're about to start the actual replacement of the HDMI. And yes, it shows that we are live streaming on the actual repairs. So let's go ahead and get started. All right. So first thing we want to do is get this HDMI off. As you can see, it has kind of a, well, quite clearly a de-stressed back here. These are the pins that should be, let's not use our soldering tip for that. Okay, so see, those pins should have been forward. Those were actually the pins inside of your HDMI connector, and they had been pushed straight back through because obviously somebody was trying to force this to work, as you can see from this split here. And this is actually indicative of a damage that is caused by taking your HDMI out and pulling it from the side. So they either were trying to put it in like this, or when they pull it out, rather than pulling straight back, they pull to the left or the right, and it causes this little spatial gap down here, which is a sign that this was just improper insertion. Now, they might have been putting it in like that and wiggling it back and forth because the pins were already pushed out, and they thought wiggling it with way too much force would correct the issue, and that never works. That's probably 75% of the HDMI replacements that are required for PlayStations is because it needed to be treated gentle, and when things don't work right, we tend to get a little angry. I myself have done the same. Alright, so first step actually is to put on some gloves. I noticed that as I was looking through my microscope. We're going to be dealing with flux, so we want to make sure that we do that. That's snap of latex that every guy in their late 30s dreads to hear from a doctor. Alright, so now we've gloved up. Our next step is going to be, well, another thing that I noticed with playing with this is we need to clean the tip. So when you're starting your repair, always make sure your tip is fresh and that it's not looking as junky as that. So we're going to turn some heat on. My Metcal station went down, which I really like for the PS4 because it has such thick thermal sinking to it that it needs some really fast recovery, and that's where the Metcal with it uses a frequency generator. It's what is it called? Basically their method is probably going to be the fastest thermal recovery time you can get out of an iron. And I haven't even applied any flux yet, just heating it up and giving it a rub. You can see that tip is much cleaner and better looking, but we're going to go ahead and apply, and sorry, I think I said flux, we're going to apply some solder. And as far as solder goes, I only now use keister solder. I used to buy the cheap stuff, and it just, you get nasty joints. It does not bond as well. You can eliminate a lot of soldering frustrations by dumping the eBay junk, dumping the AliExpress junk. Get rid of all of that knockoff solder and buy yourself some good quality. I mean, just look at it. That's nice, silvery, and shiny. What you'll notice with if you're asking yourself, do you have good or cheap solder? You probably can just take it and do what I'm doing here. Let's see if we can see this. If you're not getting a nice shiny bead like that, and we can even add a little bit of Amtech flux. If yours doesn't bead up and get nice and shiny, if it still looks like a clumpy pile of dirt after you've done, and you can see all that has broken off is a combination of flux and nice fresh solder kind of going back over and cleaning this tip up. And now if we look at the tip, you can see that it is quite shiny, except for up at the top where we're not worried about getting solder to. And I've tried lots of different mats. I am going to try to help people learn from my mistakes over the years. I've bought so many different things trying to find the right setup. And the green mats, they're great. They're ESD. However, they cannot tolerate heat. You're going to have to put a silicone mat down if you're using a hot air station for these types of repairs. Unless you're doing an elevator repair where you're off of the table, you're going to end up burning up every mat, every table. I do always use just a solid wood table top. So yes, I have actually scalded and sent one smoking before from not paying attention. So silicone mats are what you want to use. All right, so our next step, now that we've got our tip cleaned and it's ready to go, we can go ahead and start working in some solder into this HDMI. And this is going to make it so much more simple to get off because, like I mentioned earlier, PlayStation just uses the thickest heat sinks you could imagine. As you can see here, all of this is copper grounds. I should say thick, huge, massive ground planes everywhere. It's a multi-layered board. So these ground planes are going to start sucking off heat, and it's going to make it extremely difficult to get this thing to come out of those mounting pins unless we first get everything kind of lubed up and ready to receive that heat as rapidly and as efficiently as possible. And I am using this tip specifically for removal. Once I go to put all this or replace it with a new one and kind of put all the pins back to their soldered joint status, at that point I'm going to change out to a much smaller tip so that I can work these. And it's not that you couldn't do it with this tip, but we want to be as efficient as possible, and a smaller tip will help us do that. Alright, so we're going to flip the board over and get the backside, and going through like this and getting it all the way around may not be necessary. You might not have to do it. However, for me, I found it to be the best and most reliable method for getting it off the quickest as well as the safest, because yes, you can cause a lot of damage to this HDMI port if you don't ensure that you get heat thoroughly through it. In fact, I've seen another local repair company where they had such a hard time getting heat to the HDMI, and here is a issue of where I'm trying to make me work for the board versus making the board work for me. And I didn't need to move it from where it was at, but I needed to switch hands between solder, and also I'm using a boost setting on this one. Now if I was using the Metcal, that would not be necessary. However, with this one, I have to boost it up to a higher temperature and then let it fall back down. If I kept it up at that high temperature all the time, I would end up burning out this tip, but that boost is necessary for it to be able to really see how it's worked that joint. All right. Okay, so next step will be now we're going to use a combination between the soldering iron as well as our heat gun. And so that we don't thermally stress this, we're going to start out with a lower heat temp, and then we're going to work our way up. And I normally have, and I'll show you a little trick that I've devised once I find where I stuck the part, but heat shrouds are something that can be very helpful. I have spares from boards that I've taken apart of this. We could use this, and it would allow us to kind of, this part here, allow us to cover up some of the areas that we don't want to get heat exposed. However, I have one that I've made that is more suited to the size that I want. You can shape these in any shape that you want. I take Coke cans and I cut them, and then I form and fashion them into heat shrouds for the components that I want to work on. And I have one somewhere here on the workbench, but it looks like I moved it when I was rearranging things for live streaming, and I'm not sure where I put it. So we're going to use a poor man's fix. Not that a Coke can is an expensive man's, but this is kind of just engineered on the fly. We're going to take, I don't know if you can see what I did there, but I took a razor blade and I'm using it to cover up that component. Versus stopping everything that I'm doing and then looking for that tin shroud that I've made. One thing I meant to do, and I actually put it down, I'm not looking at what I'm doing here, so hopefully I don't go pointing at the wrong thing. I am looking at my screen because I actually should have this up just in case somebody does happen to join in and wants to send a chat. I will actually see that that is taking place. All right, so we've been well over the amount of time, and normally it would not spend that long. So I'm going to phase 2 of heat. I probably would normally only put about 10-15 seconds of heat on phase 1, but because it is such a low temp, I was at 175 degrees Celsius. It's not going to be an issue for me to sit there longer. Let me just do phase 2 here for a second. And so that this solder ball doesn't go and slide up under there and get on any of the joints that are up underneath the shroud, we remove it. And so now you can hear that airflow just kicked up. We're on our highest airflow and highest temp setting. And because we've saturated that underside with all those pins with solder, and this is RMA solder, which is mildly activated, which means it has flux already built into it. This component will eventually just drop out. And that's the best method to remove that. I actually have a vacuum desoldering station, and I thought maybe it would be beneficial to try to vacuum desolder those pins out. I could use less heat. You know, anytime you add heat to a board, you run the risk of causing a component to fail. Such as if this encoder that is up under here was on its last leg. That heating process, because it does take such a large amount of heat to get those legs to free all the way through the board, it could cause it to go ahead and go from on its last leg to dead. Doesn't happen often, but have seen the case where it does. But if it does happen in that case, the board that chip. The board is still good. HDMI encoders, no matter what people tell you, those are extremely fixable. The parts are out there, and anyone that's worth their salt in repair can get it done for you. All right, I want to make sure I'm lined up here on the screen. That hot board just melts that flux as it comes out. And this is Amtech NC559 V2TF. Very good flux. There's a ton of fake stuff out there in the market. There are legitimate guys like Louis Rossmann. I think there's another one that sells on Amazon that buy it direct from the manufacturer. I just go ahead and make the investment, and I buy these 10 tubes at a time, and I'm usually getting some solder balls as well from Amtech, and it's, what is it, 15 bucks a piece plus shipping when you buy them at minimum 10 tubes. So one tube lasts you forever. 10 tubes will last you a lifetime. They technically are only good for, what is it, a year? But as many others have said, if you're refrigerating them, because these are non-refrigerated or non-temperature, as long as they're in room temperature, they're fine. You don't have to refrigerate them. But if you do, plenty of people have said they last longer, and even without refrigeration, I've seen them last longer than a year. In fact, I think I'm getting close to expiration, and I still have 3 more tubes, and I'm going to continue to use it. I'm not going to throw it away because it'll still be good. Okay, so we go next. Lost my train of thought there talking about flux. We want to now desolder, and this is where it gets a little bit tricky, where you can cause some issues, and this may be an opportunity for me to show you 2 different things here. One, I don't know if you can notice, this is not quite the same, which they are different widths, but what you want to notice is the thickness. There's a thickness difference. This was bought, I believe, off eBay or AliExpress long time ago. I still have it. I still use it. It just doesn't work that well. I only had like 3 rolls of this, and I still have, I think, 2 of those 3 rolls. But this stuff I bought direct from the manufacturer supplier here in the US. This is authentic Gootwick. And I always thought copper is copper. I mean, what can one company be doing that the other company isn't? Yeah, it's a knockoff, but it should be as good. Until I used the real Gootwick. And it made a massive difference. All right, so I'm going to go ahead now and change tips. And I'll probably go with a hook tip for this particular moment. This is a BC2, so I'm going to set that tip setting. Alright, so this, just to show, this is basic temp. In fact, that works quite well for these. But when we go here, it's not going to do anything. It will not clear that solder joint. So we want to evacuate this. And there's plenty of people that say, don't worry about it. Just leave it in there. And I do have the quick 861D, and I'm jumping thoughts here, but that's because I'm about to change this out, and I am putting my tip on so that I can have focused airflow. And the problem with this is I have to turn off the machine to put the tip on, because if I lift it out to put the tip on, it instantly turns on. But I do love this hot air station. I've had probably 4 different other types that were always the cheaper versions. I bought this about a year ago. I had first seen it on, what is the guy's YouTube from the UK. And since then, I think everybody in the repair industry has picked this up. Now, my understanding of this particular machine, and one of the reasons why it works so well, is that this is a licensed machine design, and it's been tweaked over time, but this was the core of this, and the company can feel quick if this is completely wrong, then feel free to make a comment and say that it is. But the core mechanics of this machine were designed from, what's the company, not Pace, Weller. It was a Weller design. Now you can see by adding hot air and just using the desoldering braid, or wick, whatever you want to call it, we are able to evacuate those holes. And the reason why this becomes extremely important is when we're putting in a new HDMI, we want to make sure that it's aligned. And if there's solder all buggered about inside of those joints, we're going to have a really hard time lining this up. But now, because you can see we've got full movement, left, right, forward, back, we can get our wiggle just right until we have this lined up and all our pins in their proper position. And I'll show you that in a moment. But for posterity here, we're going to go and do some quick test and measurements. We want to make sure this area cools down. We can actually give it a little quick clean with some isopropyl. This will help to kind of wick away some of that heat and also prevent flux from building up. And this is where I'll jump around. You'll get to see my ADD throughout these videos. But you'll hear different opinions on flux. Too much flux, too little flux. Is there a right amount of flux? The answer is yes, and the answer is no. The right amount of flux is what you're comfortable with. Too much flux will not destroy anything. Too much flux can make your cleanup a super pain in the butt, but it's not going to hurt the board. Now, if you were using extremely high heat and you added flux plus high airflow, too much flux in the sense that it could flow all over these components, and then that airflow then uses that as an opportunity to blow components away. So in that sense, is there such a thing as too much flux? Yes, absolutely. But in terms of, will too much flux make the job harder to do on the joint that you're trying to work? No. Will it make it harder to do if it removes a bunch of other jointed components from the surface mount? Yes. So take too much and too little with a grain of salt. The better answer is find what works best for you. All right. So what we have next is we're going to do some quick diode tests to see common failure points on the board. And that's going to be our filters, which these are, and again, every time I try to think of it, my mind goes blank. These are diodes. And I've seen some reference. I'm actually still looking for the correct part replacement for these. Currently, the only way to source them is to pull them from dead boards. There is certainly an equivalent that can be purchased. However, finding the right size at the right specifications is just a pain in the butt, because until Right to Repair wins, we're not getting schematics and documentation of what component goes where. It'll be nice if that day happens, and it looks like it's an inevitability. It just hasn't come yet. All right, so the way a diode works is you may not be able to see it on this one, but it is, at least to me, very clear on this one that there's a line on one side. And from that, that side is blocking. So if we put the positive probe, the red probe, to that side on the blocking side, and then our black lead on the opposite end, we should get my probes weren't pushed in all the way. All right, so now we should get OL, which means either open line or over limit from what it can detect. And in this case, it means that it's an open line. It can't actually send current from one side to the other. But in this case, we may actually be getting current flow through. No, we still are dealing, I bet you I know what it is. I like these tips. I bought this new, and I really like it. No, I know exactly what this is. Okay, I'm going to have to grab new batteries. What I was going to say is that I bought this not long ago, and I am thoroughly enjoying it, but every now and then they will back out. And if they do not have a fully seated connection, they will run into an issue. It probably will be beneficial if there was some type of locking tang like you would see on a washer or a nut. But these are awesome because they're replaceable. They're extremely sturdy, even though they're a fine point. So I was impressed with this probe set. And because these fine tips break so much, I had just been buying cheap sets because I would go through them quite often. But these appear to be much more durable. I'll be right back. I need to grab 2 batteries for my multimeter. All right, so I have the batteries. I just got to get them in. If you're getting inconsistent readings from your multimeter, probably beneficial to take a quick look to see if it's telling you if the battery is low. If it is, you'll need to replace them because you just will get all kinds of crazy readings if your batteries are on their way out. And crap. Okay, these are actually, it's been a while since I've had to replace them. This particular meter is AAA's, not AA's. So again, I will be right back. All right, so we got AAA batteries. I was tempted to buy Dave's multimeter. However, I decided to wait a little bit, and then before I knew it, time had passed and it was sold out. However, one day he may reopen that. I'm not sure if they're going to make additionals. I haven't seen much chatter about it, but it looked like it was decent quality and certainly had good battery life. This particular one, cheap multimeter, it doesn't really last that long. It goes through batteries quite quickly, and that's usually because it doesn't want to shut itself off and I forget to turn it off. Okay, I am still getting a reading in diode mode when I should be seeing open line. Let's do continuity test and we'll come back to diode mode. Alright. So what we're going to do now is do a continuity test, and this is one of our other posterity checks just to make sure everything is up to snuff. Alright, so now that is supposed to, as you can see, this is a ground line. That is also a ground line. Up, coming straight out the back here. And then this shouldn't. Alright, so all of our lines that should not beep do not. What we also want to do is check between these 2 points. And what this actually does is give us a quick way just to see if there's a short on the back side leading to the encoder. Now there could be a break in the lines, but from looking at this one, there was no signs that that was going to be an issue. So rather than taking off the plate and checking, you can test continuity between the filters underneath by contacting their 2 points on the surface. And none of those went off on us, so we can be sure that these are not connected. Now they may be severed. They could be blown on one line and we still have an issue. That is where our diode mode measurement, now I'm getting OL. So not sure why it didn't want to cooperate earlier, but it is functioning now. So this time we're in the reverse of what we were doing before, and this should give us a reading on the meter because as you can see, we are putting the positive probe to the side that does not have a blocking line, which means that current can flow through. And that is where when we contact these probes, I get a reading of 0.50. And 0.51. We're going to reverse it and just make sure that we have a OL on each side. OL, OL, and open line. So we're good there. Now this one again, our red probe, because this now has flipped on us, our red probe is on the non-blocking side, which means current will flow through. And on this one we have a 0.538 reading, which means it should be good. And we are OL on this side because we should now be blocking, and we are good. Alright, so OL again. And on this side we should be getting a reading, so we're going to recheck just to make sure we're seated properly, and we weren't. And I'm applying very little pressure because as you can see, if you apply too much, and not much at all was applied, just resting my hand down on it was enough that that tip is slightly bent. So you don't need a lot of pressure, you just need to make contact. And there is probably a conformal coating on these joints, so if you're really uncertain that you're getting good contact or not, you could simply just go back over these with a soldering iron, and that would remove any conformal coating and ensure that you have a fresh, clean, uncorroded joint to, or unobstructed joint to attach to. So we're getting a reading of 0.58, and we're good there. All right, and then OL, so we're good on that side. All right, and really, for kind of an initial basic test, that's all you need to check. It doesn't mean that there's not anything wrong with the other circuitry here. However, in terms of where you should spend your time, that's as far as you want to go until you've got the HDMI back on. You're now going to connect it, and if it fails, you investigate further. If it's functional, you know that your initial inspection signaled that everything was okay, and you can move on. Now, to put on this HDMI, what we want to do is we want to get flux down into these little sockets here, mounting holes, and then we want to get a little bit of flux and like I said, it's everybody's personal opinion, but for me, that might have been more than I wanted. So I'm going to clean that up a little. And before we move on, we want to go ahead, and for this I like to use, again, keister solder, but I'm going to use a much thinner strand of solder. Just gives me a better level of control. But we're going to go ahead and pre-tin up these joints. We're not going to pre-tin the holes, because if we do that, they will now be obstructed and we will not be able to slide our HDMI port in. So what I'm doing now is I'm just aligning, and then I'm kind of giving a base connection to the board with the pins. This is not my actual soldering of them. I'm just trying to lock them in position so that it doesn't move, and while I'm trying to solder in those mounting pins, because I want to make sure that I'm situated in the correct position, because if I just solder these mounting pins on the side without actually locking these in place, I'd have an issue. It would wiggle. It would move to the left and the right. As I pressed here, it would slide that way, and as I pressed there, it'd want to slide this way, and we just wouldn't have a very well-aligned HDMI. Also, it may fall, as you saw earlier, I was pressing down on the top. I wanted to make sure I have a flat mount and not a lifted up or a pointed down, because if it's not properly aligned, when it goes to get back into the case, it's going to be misaligned with the opening that is in the plastic housing for the PlayStation board. And if that takes place, you're going to have a customer that then end up breaking the HDMI, but it's at no fault of their own. And I clean that little bit of excess solder off of my tip. And I come back with that same tip that I was using earlier, and I'm going to flow this joint with that solder on it to help it kind of sag down and get suctioned into that hole. And I want to allow that side to heal, so to speak, thermally. It's going to cool off so that it's not hot, wet, and pliable when I go to do the same to this side. All right. And now, before I actually get into doing my final corrections on my pins, I flip the board over and get to the back side. so that I can come back at it and the best method I found for this is just suck all that solder onto the tip. Let it sit there like a bead, and you're just going to hang it out. We're going to turn this temp all the way up on the soldering iron. In fact, this is not the most comfortable position, so I'm going to rearrange it. But I need to make sure that it's in view for the stream, and then this is much better. This is a better way to have it situated. I'm not trying to fight against this. I can get to all sides of these pins without trouble. I'm going to apply some flux on the back side. Not a lot, but just a little bubble of it. And you could probably call this one of my little signature moves here. I like to kind of make a little solder train here across these joints. And basically all that's doing, we're going to catch that on the other side, is just giving them a solid connection from front to back so that it reinforces the joint. When the customer is now taking their HDMI in and out, and if they do happen to put upwards or downwards pressure on it, it's going to help to stabilize that, because now those two pins can't move freely between each other. They have this bridge across them that acts as a support strut, making sure that they both try to stay on a level plane together. And there was our little solder piece that came through on that side. And put a little bit of fresh flux down on those pins. And now we're going to go ahead and reestablish these joints. And you will get some bridges, not a big deal, you just move on from it. We'll go back to them and clean them up. I'm going to shut that door to block out some of the noise. And we're really on the last steps here. We're going to take this, use the good old-fashioned drag method. And now we're going to change it just a little bit. I'm going to find the best orientation here. The idea is to, by dragging, we're going to move flux from one area where it's oversaturated, sorry, not flux, solder, from one area where it's oversaturated to another area where it may be undersaturated. It doesn't always work out exactly as intended, but we eventually get there. But what we do want to make sure is that these joints, as you can see, need to be solid from the pin to the board, and then there should be no bridging, which I can see at least 2 bridges right now. Not obviously the one is very noticeable, which is right there. That's from the right side. We're looking at 1, 2, 3, 4, 5, 6, and 7th pin are bridged. And if we go 8, 9, 10, the 10th and 11th pin are bridged. Possibly over here on the end, but I think that's actually just a reflection. So we're going to try to get those last 2 little bits without using the solder wick. If I can avoid solder wick, I do. It's just once you start using it, it's going to take off more solder than you want it to, and then you have to put some back, and then it's better to just learn how to manipulate your iron, your drag method, your little tips and taps, as I like to call them, as I'm doing right now. But sometimes when you just get too much underneath, you got no choice but to use it. But I think in this case, we're going to find that that is not a problem. So as you can see, we've got a fully soldered joint. We're going to clean this up now. And sometimes it will take more than one cleaning. It doesn't always come off right away, but you do want to make sure you just don't have all that flux built up and gunked up underneath there. Otherwise, you'll run into issues where that flux remaining. And again, I believe this particular type is no clean flux. However, if you read the full data sheet, it says in order to be no clean, you would have had to have heated it up to its, what they consider its, more so what I would consider a BGA profile for. You would have to heat it up to around that like 225 degrees Celsius mark, and you would need to maintain that temperature for a certain amount of time. And those of us in the repair business that do reballing and reflow know exactly what I'm talking about here. There is a phase and stage of timing where I guess you should actually call it a phase state change, where it goes from a liquid or it's kind of greasy like substance to a hard coating. And if it does not change phase to that hard kind of crystalline like structure, then it is no longer no clean. It is still in its gel-like, and while it's wet and gooey, has the ability to absorb other properties like dust, dirt, metal chips, flakes, whatever that may be floating around, little balls of solder residual. And in fact, did I just see some like little metal fleck? That might have been. But stuff like that is going to stick to it really well. And if it does stick to it and then happens to also make contact with another joint, then you have a short. So you want to make sure you clean all of that flux out. And that's where I said the part of, is there such a thing as too much flux? No, in terms of working a solder joint, but in terms of cleanup, and ensuring that you don't have problems down the road, yes, there can be too much flux. Because I have used too much flux plenty of times on HDMIs, and I spent probably an hour working it out of the joint. In retrospect, it would have been simpler and faster to completely take the HDMI apart, clean it, and redo it. But sometimes I like fixing problems the hard way. They say the best lessons are learned the hard way, and you learn what's your comfortable amount of flux by having to do an overly intensive cleanup. Now, isopropyl in a small layer, not an issue. Isopropyl will evaporate, and a thin layer of residual flux is not going to create an issue. All right, so what we're looking for now is we're looking down and into the joint. We want to see that there is a clear spatial gap between each one of these pins, that there's no bridges between them. And if we wanted to go the extra step with that isopropyl underneath, but again, it's really not necessary, we could take our air gun and we could blow air up under there, and that would eject all of that remaining isopropyl out of it, and anything that it couldn't eject will just evaporate off because there would be so little substance remaining. Other than that, like I said, this is a repair for another retailer. So I do not have the base, I do not have all the components. So we're not going to do a test, but I have hooked up my system so that it can be connected and I can simply switch frames. So in future streams, I will actually be hooking up the full device repairs and doing play verification in the stream so that we can see that that takes place. Also, I don't just repair PlayStations and HDMIs. If it's electronic, I work on it. In fact, not long ago, I had a slew of pinball machine parts on this table. So the repairs that take place on this channel will actually change and evolve. You'll see different things come across. If there's particular videos you want to see repairs of, feel free to post those in the comment section. Let me know. If there's questions that you have about any of the particular steps or materials that I used, feel free to ask. Other than that, it's been fun, and catch you on the next video.